Hey guys, we're going to prove theorems on corresponding angles. What does that mean? We're going to perform proofs on alternate interior angles and corresponding angles and also alternate exterior angles. So let's take a look at some definitions. If you watched my last video, you'll notice that this time I'm not fighting trying to write in these tables. Now let's talk about corresponding angles. Corresponding angles exist when we have parallel lines. And essentially what it's saying is that if you have angles in similar positions, they're congruent. I took a second and just highlighted the different sets of corresponding angles. Hopefully that makes the pattern of how angles correspond a little bit clearer. We have same side supplemental angles or same side interior angles, depending on who you talk to. These are angles that exist in parallel lines, and what they do is they will add to equal 180 degrees. The last definition, which is vertical angles, was something we proved in the last video, and now we can use it here. One point I want to bring up. If you're looking at these angles and recognizing some patterns, you should take the time and just appreciate that this is how the ancients viewed building theory. So, oftentimes, as we talk about how ancient structures were built, they really didn't have too many numbers to work with. They didn't have long measuring tapes or laser levels or all those other equipments that we have now. What they had was this. And this is how often they knew that their structures would be sound. Okay, let's take a look at a couple of examples. I should point out, before we dive into this example, if you have not seen the previous video, I would definitely watch that one first, if you have a very weak understanding on proving. So, here's what I did. I copied the given down verbatim, the best that I could in that line, and the reason why I knew it was because it was given. What I want to prove is that these angles are corresponding. So, the way I'm going to do that is I'm going to look back at my definitions and see what I can create here, what situation I can create. And the first thing I notice is that I could create same side supplemental angles or same side interior angles. I could create that right here. And I'm going to call this angle 3. So now I created same side supplemental angles. What I think I want to do here, creating my strategy first, is I want to use the transitive property. So let me get started. So the first statement I'm making is that angle 3 and angle 2 are 180 degrees. And that is because they're same side supplemental. Now what I'm going to do is employ the addition property by stating that angle 3 and angle 2 equal 180, and that is the addition property. Or I could have written property of supplemental. But as I mentioned in the last video, I'm trying to keep this as simple as possible. Now, I also notice that angle 1 and angle 3 make a linear pair. So in other words, angle 1 and angle 3 are making a straight line which equals 180 degrees. Then from there, I am going to employ the addition property again. So now I mentioned this in the previous video. This is precision in language here. So what I am doing is first I'm stating what I know. So I'm saying angle 1 and angle 3 are 180 degrees because they are a linear pair. Then I am stating how I'm going to use that information by employing the addition property. What I'm going to do next is I'm going to employ the transitive property. And what I am saying here is that since angle 3 plus angle 2 equals 180, angle 3 plus angle 1 equals 180, I could substitute one of those 180s for the expression angle 3 plus angle 1, which is what you're seeing. And I've again created this situation where I have angle 3's on both sides. So I can now subtract them from both sides. Okay, so I've gotten down to angle 2 equals angle 1 by subtracting angle 3 from both sides. What I'm going to do now is add the formality where I make clear my last statement that angle 1 is congruent to angle 2. And I get that it looks a little silly. You just said that angle 2 is equal to angle 1. Why are we making the statement that they're congruent? Sometimes you see it in proofs, and sometimes you don't, so I just want to present it here. But, as mentioned in the last video, that equality is a numerical concept, where congruency is a physical concept. So equality is stating that the two angles are numerically the same, while congruency is confirming that they are physically the same. And I'm going to stress one more time, if this looks very foreign to you, I highly recommend go watch the previous video where I go into all of this in significantly more depth. Okay, let's take a look at the next example. So, first thing I did was copy down my given again in verbatim, which was very difficult to do. I had to write it 2 or 3 times. Now, in this example, I want to prove that alternate interior angles are congruent. The previous example proved corresponding angles are congruent. What I think I want to do here is, instead of following through on the previous example, the same steps, I want to do this a little bit differently. And the reason for that is, I want to show you that once you have a definition down, you can just use it. That's the way proving works. The information is building on the previous step. So, let's take a look at that. What I did is I introduced angle 3, and I know that they're congruent because in the previous proof, I proved that those angles 1 and 2 are congruent. So I have proven that angles are corresponding. So now I'm going to use that. My first statement is going to be that angle 2 and angle 3 are congruent. And I'm going to justify that by making clear that I recognize them as corresponding angles in the reason side. I should stop and point out that some formalities will require you to actually insert the line that angle 3 is being introduced. I'm not going to go that in depth here. I just want you to understand how you could use definitions to create a proof. Next, I immediately noticed that angle 1 and angle 3 are vertical. Looking back at this definition of vertical angles, I see that I have angles making an X like this in this situation here. So I'm going to state that angle 1 and angle 3 are the same because they are vertical angles. So now, look at what I got here. For starters, I have angle 1 is congruent to angle 3, and I have angle 2 is congruent to angle 3. What that means is I can substitute angle 1 for angle 3 or angle 2 for angle 3. So, therefore, angle 1 and angle 2 have to be the same. In the previous example, you saw me achieve the same thing with transitive. by subtracting angle 3 on both sides. I didn't employ the addition property here. I don't have to. Because I see that angle 3 is congruent to both angle 1 and angle 2, that means angle 1 and angle 2 have to be the same. So I've gotten to my conclusion, or I have proved what was requested of me to prove. Now, I want to point out that I could have followed the same exact steps as I did before. So I could have, instead of placing angle 3 here, I could have placed it here. And I could have created, once again, that situation where I have a pair of linear pairs, angle 1 and 3, that equal 180, and a pair of same side supplemental angles, 3 and 2, that equal 180, use the transitive property and then subtract it. Either proof is valid because they both get to the same conclusion. But in this case, I was able to use my newly found definitions to create a more efficient proof. So if you ever wondered what the benefit is of expanding your vocabulary, here it is. I could create a much more efficient argument and get to the same conclusion, doing a whole lot less work, mind you. But it takes a whole lot of experience to get here, and oftentimes a whole lot of planning ahead of time before you even start to make your argument. Okay, let's look at the last example. In this example, I want to prove that alternate exterior angles are the same. Here we go again. I could use that first example. It would take a while, significantly more steps, because I would have to make a set of same side interior angles here, a linear pair here, and I would probably have to use the transitive property twice. So in other words, it would be double the first example. I want to make clear, there is nothing wrong with that. If you're comfortable in creating this proof that way and you see those steps through, or you could envision them before you go into the actual proof, you should do so. It's the way we learn. We learn through experience. Oftentimes when we do something the first time, we do it the long and the hard way until we do something a couple of times and then start to see more efficient ways. But for the purposes of this video, I want to present to you how to use those definitions to get to that point that we have covered. And the definitions I have at my disposal now are vertical angles, alternate interior angles, and corresponding angles. So what I see I could do is I could create a set of vertical angles. And so what I did is I see two pairs of vertical angles here. And I could really number them whatever I want. But I'm going to number them angle 3 and angle 4. From here, I'm going to make the statement that I have two sets of vertical angles. But here's another factor. Angle 3 and angle 4 are also alternate interior. So I could use that as a fact too. So, hear out the argument before I write it out. Angle 1 and angle 3 are the same. Angle 2 and angle 4 are the same. Angle 3 and angle 4 are the same. That means angle 1 and angle 2 are the same. That's the way I'm thinking this through. So, let's write that up. So I added to my argument, angle 1 is congruent to angle 3 because they're vertical angles, and angle 2 is congruent to angle 4 because they're vertical angles. I've stated this before. You could use the same reason for multiple different statements, but typically your statements from line to line are unique. Now, what I want to do is I want to use my previously proven definition, where I proved that alternate interior angles, such as these, are congruent. So I created that same situation here. These are alternate interior angles on both sides. So now what I'm going to state is that angle 3 and angle 4 are alternate interior angles. So I've shown here that I have angle 3 is congruent to angle 4 by alternate interior angles, or property of alternate interior angles. So you kind of have to look at a pattern here, and this is pretty tricky to see, so just take a moment. As stated at the start, angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Angle 3 is congruent to angle 4. So these two angles here are the same. That's stated here. That forces us to recognize that. So as a result, I see that angle 1 and angle 2 are the same. So what I'm arguing here is that the entire time we've been looking at these angles, we're really staring at the same angles in relative positions of each other. They just have special names because of their position. So now what I could say is that I can substitute these angles however I like. Well, what I want to prove is angle 1 is congruent to angle 2. So I'm going to make that statement now by using the substitution property. And here it is. Angle 1 is congruent to angle 2 because I could use the property of substitution, or if you prefer to write substitution property, I don't think it really matters, to support that alternate interior angles are congruent. Okay guys, like I've mentioned repeatedly, learning to prove is a long journey. You can do it. It takes a little bit of time and a lot of patience. But the life skills you learn from proving this way will pay back in dividends. I hope you guys found this video helpful.